Hi guys, if you are viewing my channel first time, please subscribe to my channel for more updates on embedded systems. Today we are mainly discussing about on Zigbee module interfacing with 805 microcontroller. How we are going to interface this Zigbee module with the 805 microcontroller. How we are going to receive the data from this Zigbee module to the 805 microcontroller. How we are going to process the data within this 805 microcontroller, that we are going to discuss mainly using the embedded C programming today. And first of all, we should discuss about the Zigbee wireless communication. And this is a module is available XB24 cap IT iPhone 001 XB. Okay, this is a XB module. This is a Zigbee module, and this is also one of the Zigbee module. For example, this is a mainly Zigbee wireless communication one to multi-point. This is one of the feature in our Zigbee communication one to multi-point. If I want to communicate personal computer to the another personal computer, and also one personal computer to the 10 personal computer. This is a mainly use case of the Zigbee module, mainly usage. Next here IEEE 802.15.4. This is a standard for this communication one to one or one to multi-point. This is already standardized communication. And 2.5 wireless communication. Mainly here we are communicating one to one Zigbee module via wireless. And here 250 kbps. If I want to transmit from one personal computer to the another personal computer, the maximum baud rate is 250 kbps. And if I want to communicate with the Zigbee, always we should use a UART protocol, Universal Asynchronous and Receiver and Transmitter. Okay, we have only the TX pin and RX pin. We should always transmit the character by character, and also we should receive the character by character. Okay, here serially we are sending bit by bit, and it will get modulated and it will be transmitted via air using this 2.4 gigahertz. Okay, similar way wirelessly we are going to receive at the receiving side. Here this is always receiver, this is always transmitter. Here we used to receive wirelessly, and that will be again convert demodulated and bit by bit transmitted to the this computer. This is a mainly communication between the one to one or one to multi-point mainly. And in case of multi-point, all the paired modules are available. Always it will transmit from here to the all the multi-point. This is a mainly use case of the XB module. And here we have the XB module is already available with UART and with RS-232 logics also. And also some modules are available with TTL. If the TTL module directly we use to interface with the microcontroller. If it is RS-232 format, if the Zigbee module is giving with RS-232, so we should convert the RS-232 to the TTL. We should use the MAX232 IC. This is the way we used to interface with the microcontroller. Okay, here always our microcontroller working with the TTL logics, transistor logic, always 0 and 1. Logic 0 is the 0 volts, logic 1 is the 5 volts. But RS-232 logics are different. Okay, that's why we are using this MAX232 IC to convert the voltage levels to the minus 3 to minus 25 to 0, and plus 3 to plus 25 to 1, logic 1. Okay, this is a way to convert. We are using this MAX232 IC. Okay, this is a mainly to communicate with the microcontroller also we should use UART. And this TX and RX pin we should connect with the cross connection, so that we can able to communicate effectively. Okay, we are going to implement one of the use case today by using the embedded C programming. Left side, from the PC I am going to transmit some data. Only this Zigbee module I am going to interface with the personal computer in the left side. And this right side, this Zigbee module I am going to interface with the microcontroller. Okay, left side always from I am going to connect with the PC, and right side Zigbee receiver I am going to connect to the microcontroller. Okay, here I am going to implement on use case. Write a embedded C programming for home automation using Zigbee. Okay, via Zigbee, we wanted to automate the home. Okay, here if I want to turn on the fan or turn off the fan, and also turn on the light and also turn off the light, this use case we are going to implement using the embedded C programming. Here I always receive some data from the always from the personal computer via Zigbee, and whatever the received data we are going to transmit bit by bit to the microcontroller. Okay, here always we should use some data transmission from the PC to the microcontroller, so that I am using some here we will use some L1 on. Okay, this is the data I am using, L1 off. Okay, next similar way, fan 1 on, next fan 1 off. Okay, here I took the four use cases. For example, if I want to turn on the particular light, so that I should send this L1 on, so that we can turn on the particular light. For example, if I receive this data, I should turn on the particular light one. For example, similar way, if I want to, if I receive this L1 off from the PC, for example, from this PC, first I received the L1 on, so that I should receive here the same data. And if the L1 on this data is received, simply I should turn on that particular light one. Okay, similarly, if I received the L1 off from the PC to the this Zigbee, and whatever the data received by the Zigbee, simply it will transmit to the controller. And here I received the L1 off, so that I should turn off that particular light. Okay, similar way, if I receive the fan one on, so that I should turn on the particular fan. Okay, next here fan one off. If I receive this command from the PC, so that I should turn off the fan. Okay, this is a use case we are implementing now. For example, if I want to interface light or the fan, always it is operating with the 230 volts. So we should always use the relay circuitry. Okay, this is already we designed in the previous sessions. If you want to interface that whatever the bulb or the fan, we should always use this circuitry. Okay, currently I am going to use only the LED to just show the particular LED for the fan I am going to indicate, and particular LED for the light. Okay, that I am going to take only two LEDs I am going to represent. And right now we are going to design the hardware. After the designing the hardware, we will go for the programming. Okay, here we have LCD, and also we need two LEDs. Okay, to indicate the fan, and LEDs to indicate the fan or light, we need two LEDs. Okay, right now first we should take the virtual terminal to receive the data from the microcontroller, or to the transmit to the microcontroller. For example, always Zigbee module has two-way direction. This TX I should connect to the RX of the microcontroller. This TX I should connect to the TX of the microcontroller. This RX TX. Okay, this is always cross connection. This we should treat as a our Zigbee module. Okay, here I received the whatever the data, and received data I should transmit to here, and based on the received data I should perform the particular action. Okay, here I should interface two LEDs here. Okay, here go to the library, and I should take the LED now, LED. And we should also take always some animated LEDs. Okay, here I will going to interface here LED 1 and LED 2. Okay, here I can rename with the, for example, here the light one red. Here additionally I am going to display the light one. Here this I will display like fan one. This is just simply text. Okay, I am going to indicate which is the fan and which is the light. Okay, this is the left side one is the fan, light. Okay, left side is the light, and right side is the fan. Okay, just I'm just adjusting the all the data, so that we can just connect simply. Okay, here, and this line I should connect to the ground. Okay, similarly this line also I should connect to the ground. Okay, here the all the common cathode configuration, all the cathodes should be connected to the ground. And here 2.2 I should connect to the bulb. This is the light. Okay, next 2.3 I'm going to connect to the fan. Okay, for example, if I receive the command like L1 on, okay, L1 on, so that I should turn on this LED. Okay, logic one. If you interface this relay also, whenever the logic one, the automatically that particular light will be on. Okay, here similar way, if I just send the logic one to here, automatically this particular light should be on. Okay, similar way, if I send logic 0, this will be off. Similar way, in case of fan also will be the same. If I send logic 1, similar way we are going to turn on the LED also with the logic 1 and logic 0. Okay, that's why here I interface instead of the fan or the instead of the relay circuit, I just interface the directly LED. Okay, by using this LED, we are going to indicate whether the fan is on or the bulb is on. Okay, here I have designed my hardware. Here from the virtual terminal, I'm going to receive the this I will treat as a Zigbee. Zigbee is a two-way communication. If I want to transmit the data, we can use, and also we can also receive the data. This is a two-way communication. Okay, both way communication we can use. Okay, here that's why I interface like this. Okay, here I design the hardware, and right now we are going to program. Okay, here I we already discussed about the RFID programming. Okay, same programming I am taking it as a reference, and from this we are going to extend our programming. Here we receive the 10 bytes of data, and based on the tag data we are going to check whether it is employee 1 or employee 2 or the invalid tag. Okay, similar way we are going to receive the five characters. Right now, if you see in the PPT, we have one, two, three, four, five characters. In each row, we have the five characters. That's why here we are going to receive only the five characters from the terminal. Okay, here to communicate with the Zigbee also, we should have the 9600 baud rate, and we initialize the baud rate initially, and after that I have initialized the LCD to display onto the LCD. And first row I am displaying welcome to, and the second row C0 means second row my project. And after some delay I just cleared the whatever the displayed data, and I displayed YT Training Institute. First row is YT Training, and second row is the institute. And after this delay, and I went to the while of one. Here we are waiting for the RFID tag. Instead of that, home automation using the Zigbee. Here I am going to display this text. Okay, here I will display like home automation using Zigbee. Okay, here I will just change the text. Home automation using Zigbee. I will just move to the next line. Okay, here this way I am going to interface. Home automation is the 80 I am displaying, and second row using Zigbee. And here I should receive only 5 characters. Okay, in case of RFID, we should receive 10 characters. Okay, here I just received the 5 characters, 0 to 4 only our loop will repeat, so that we will receive only the 5 characters. Here first I equal to 0, 0 is less than 5. This condition is true. I will go here, and I will wait until a successful one character is received. Okay, once successful character is received, I will clear the flag for the next reception. Here I whatever the received data always available in the SBUF, that I copied to the array of I. Okay, here I increased I. Initially array of 0 is my L. Okay, this is my L. And first of all, let us assume I am just transmitting this data L1 on. Okay, first array of 0 I received L, and after that I am going to increment I value. 1 is less than 5, this is also true. I am going to wait for the next character reception, and again if it is 0, I cleared for the next reception. And already this I value is 1, array of 1 is L1 1. Okay, here we received 1. Okay, similar way we should receive on. Okay, this is a A2 also. A2, here A, here A2, A3, A4, and this is not required. And here L1 wo. Okay, this way we should receive the data. Okay, L1 on. Okay, this 3 we should write here. Array of 3 is on. Okay, here this way we received all the 5 characters L1 on. Okay, after the 5 characters reception, I should go to the next step here, and here array of array of 5. Okay, until 4, here we have assigned the data until array of 4. If it is 5, okay, here I can also mention my I value is 5 only. Okay, here array of I just assign to the null character. Here see, until 4 character I will be in this for loop. If it is I equal to, again increment 5 less than 5, it is false. My I value is 5, a of 5 I assigned with the null character. Okay, right now I prepared like, okay, this L1 on null character. Okay, this is a way. If I receive this data L1 on these 5 characters, I am adding one null character at the end, so that it will treat as a one of the string. Okay, here at the end I am just comparing whatever the received data and already stored data. L1 on, I know what is the command for the light one on. Okay, that's why I stored here L1 on, and whatever the received data, if both are same, it is equal to 0. String comparison, if both the strings are equal, then it will give the result like 0. 0 double equal to 0, condition is true. Then we are going to enter inside the loop, and here I am going to display the text here, required text here, light one on. Okay, here I am going to display the required text. Previously it was like employee one, here light one on. Okay, here I'm just displayed the just text L1 on. Okay, here whatever the command we received, that we are going to display in the second row. Okay, this is a C0 means second row, 80 means the first row I displayed some character, and second row whatever we received, that I'm going to display here. And here this much delay we are waiting. Okay, I will give some more delay to visualize whether what is the data we received, and also what is displayed on the LCD. Okay, here I just given the increase the delay, and finally I cleared. Okay, in the clear function what we are doing, we just simply will clear the all the characters. Here we have the 100 characters array that we are going to clear, whatever the received data we are going to clear. Okay, this if already we completed, and similar way we are going to extend our program. Okay, here I should define our light one and fan one here. Okay, we should take two S bits. Okay, here we have the two functionalities, two special bits I am using, light one and here the fan one. Fan one. Here light one is 2.2. We connected to the 2.2. 2.3 is the fan one. Okay, here if you see light one we connected to the 2.2 pin, and fan one we connected to the 2.3 pin. Okay, here I just similar way I just connected. Okay, whenever I received this L1 on data, so that I should turn on the light. Okay, L1 I should send the logic one. Okay, initially the L1 and F1 we should turn off. Okay, L1 equal to F1 equal to 0. Okay, initially both the lights and fans are off. Okay, both are off. Okay, light and fan are off initially. If I receive the L1 on, I should turn on the particular light, and I should display the whatever the received data in the second row. First row L1 on. Okay, this is the thing we displayed, and we just given some delay. Okay, similar way for the light off, I just copied the same text here. Here light is 0, and here I should display L1 off. Okay, here I'm going to write L1 off. Okay, the same string if it is matched, I will come to here, I will just clear the whatever the logic from 1 to 0, and this light will be off. Okay, here light 1 off. Okay, here we complete for the light one, and also similar way we should extend for the fan also. Okay, similar way if I receive F1, okay, here similar way I'm just going to extend my. Okay, here I will also write else if. Okay, if fan one on, if I received the data like fan one on, so that I should display like. Okay, here I displayed fan one on, and here I should turn on the fan one only. Okay, here this is the thing I am just turning on my LED, or if you interface the relay, so that will directly turn on our completely fan. Okay, here whatever the received data I just displayed, and similar way if here F1 0, here I just clear the fan to 0, here fan 1 off. Okay, here just compared, and if we got fan 1 off, whatever the data, if I received the fan 1 off, I should come to here and I should turn off the fan, and here I should write like fan one off. Okay, here just I displayed whatever the text and cleared. And here, for example, if the whatever this data is not at all received, this four strings if not at all received, I just received like fan to on. If I receive like this, I should not turn on any of the light or any of the fan. This is like I should consider it as it is invalid data. Whatever the received data is invalid. Okay, I will just mention like invalid data. What is the invalid data received that we are displaying on the second row, and similar way I will give some delay to just visualize on the LCD. Okay, this is the program we written now. Just we will compile and also generate the executable. This is a program for the here just we will receive the first five characters. The fifth character I am going to assign with the null so that we are forming one completely one string. That string I am comparing with the whatever the already stored data. We know already one light one on means whatever the data received from the PC to the microcontroller. If I receive the light one on, so that whatever my received data it is matching with the stored data, so that I will come inside, I will do the perform. Okay, here I will just perform my particular light I will turn on. Okay, similar way here I will compare if I receive the string L1 off, so that I will turn off my particular light. Okay, similarly if I received F1 on, whatever the received data already stored data it will match to this string, so that I will just turn on the that particular fan. Similar way if I receive the fan one off, okay, here whatever the received data and stored data it is matches, then I will come inside, I will turn off the light, fan. Okay, similar way I just displayed whatever the data, and the second row what we received I am just displaying. If it is invalid data, that invalid data also we are displaying in the second row. Okay, here I compiled, there is no errors, and also I just generated the executables now. Okay, here we'll see where we are storing our executables, that we are going to check now. Okay, here go to the output, and here select folder from objects. Okay, this is the folder we are storing from the desktop today objects. Okay, here I am storing my executable and I am just selecting that executable now. Okay, here today. Okay, this is my project. From here I should select, and here always if we have any serial communication, always we should have the 11.0592. Okay, to communicate with the any external device we should always use the 9600 baud rate in all your communication. That's why I should select always the frequencies 11.0592. Okay, here I done my programming. First we should display welcome to my project, and after that YT Training Institute, welcome to my project YT Training Institute, and home automation using Zigbee. Okay, here if I receive the data initially, see both the light one and fan one both are off. For example, if I receive the data like fan one on, okay, this five characters only I am transmitting from here. Okay, here just I am transmitting here L1 on. Okay, here the particular LED I should turn on. If I just send this string, I should turn on the only this LED. Okay, here I just sending that L1 on. See here I whatever the received is L1 on. Just in the first row light one on I displayed. Here see whatever the output is completely we are turning on that particular light. Okay, similar way if I want to turn on the fan, so that I should send this string. Okay, just similar way I just copied. If I send this string now, okay, F1 on, see here F1 on, whatever the received data is this one, and just I displayed fan 1 on. Okay, see both the fan 1 and light 1 both are on. Okay, we should send from the usually in our project we should interface one Zigbee to the PC. From here we should send the whatever the commands, and this Zigbee will receive that commands, whatever the commands, and it will transmit to the PC. Okay, here I'm just comparing if it is L1 on, if it is received, I will just turn on the particular light. Okay, this is the program we written now. And similar way if I want to turn off the particular right now fan and light, so that just I'm sending L1 off. Right now I'm sending L1 off. Okay, here see light one off. Here completely I turn off the light one. Okay, and similar way for example here I'm just sending my fan one off. Right now if I want to turn off my fan one, I should send this one. Okay, here see we performed all the four use cases, and if I send other than the this valid data, okay, these are the valid data, and if I send fan 2 on, here fan 2 is not there. If I send some invalid data, it will treat as a invalid data. See, invalid data fan 2 on, which is received like fan 2 on. Okay, this is the invalid data. Okay, we should not send the invalid data. If I send the invalid data, so that we can also give one buzzer also. Okay, we can say it is invalid data. We should retry, we should always send the valid data. Okay, this is the program we written for the Zigbee communication. Usually this programming for the this is the Zigbee, and the left side we should always interface with the to the PC. From the hyper terminal we should configure with 9600 baud rate. From the hyper terminal you should transmit L1 on or L1 off, and whatever the data it will be transmitted, and here we are receiving to this Zigbee, and whatever the received data I'm just forwarding to the microcontroller, and here it will receive like L1 on. Okay, so that we are doing the particular operation, we are just turning on the particular LED. Okay, this is a simple program we written for the Zigbee communication. Okay, thank you friends, thank you for watching.